So there was a standalone question in an email that you sent me as you were studying that asked you to find the maximum and minimum value of this function on this polygonal convex set. So the first thing we need to do is make a graph of this polygonal convex set. So we're going to start by doing that. And these are inequalities, so remember there is going to be shading involved. So here's my first inequality. X is greater than or equal to 1. So that's going to result in a vertical line where x is equal to 1. And then of course we'd be shading to the right, but let's save our shading for the end. Then we have y is greater than or equal to 0, which is really just a line right on top of the x-axis, and since it's greater than or equal, we would be shading up. And then finally we have x is less than or equal to 6 minus y. Well, in this case, if you wanted to solve this inequality for y, you would move y to the other side and x over to the right, and then you would be able to more easily see what your y-intercept and your slope are. So in this case, we have a y-intercept of 6 and a slope of -1. So I'm going to go down 1 and over 1, down 1 and over 1, down 1 and over 1, until we eventually end up at this point here where x is 6. And then this is also a solid line because it's less than or equal to. So we end up needing to shade to the right of the vertical line, above the horizontal line, and below the diagonal line. So the area of interest is this triangle right here. And these problems actually came from section 2.6 in your book, and in that section you can see a theorem that says that your minimums and maximums always occur at a vertex of the convex set. So this vertex has the coordinates 1, 5. This vertex has the coordinates 6, 0, and this vertex has the coordinates 1, 0. So all I need to do now is plug in the numbers for each vertex one at a time into this function, and I will find out what the minimum and maximum values are. So for example, we've got f of 1, 5, so I'm plugging 1 in for x and 5 in for y. Well, if y is 5, 2 times 5 is 10, and x is 1, so I end up with a function value of 11. If I plug in 6, 0, I've got f of 6, 0, so I'm plugging 0 in for y, so 2 times 0 is 0, and I'm plugging 6 in for x, so I end up with a function value of 6. And then finally, f of 1, 0, I'm plugging 1 in for x, 0 in for y, so I've got 0 plus 1, which is equal to 1. So looking at these values, I can tell then that my minimum value of f is equal to 1, because that's the smallest that came out of the vertices. And if you want to be more specific, you can say it's a minimum value of f of xy equal 1 at, and then it was at the point 1, 0. And then you obtain a maximum value for the function, and the function is equal to 11 at the maximum, and that occurs at the point where x is 1 and y is 5.